Welcome back, folks. One more example. We're going to abuse this example. We're going to use it over and over again. I'm going to analyze this circuit using the seat of the pants method. And then I'm going to use the same example to introduce mesh analysis, which will be our first method of circuit analysis that's a little more organized and scales nicely to really big complex problems. But we're going to start with this problem, which you can't see. I'm pointing at it right now. We're going to start with this problem, and it's a bite size, right? It's small enough that it's not going to be too much to introduce the method of analysis. It's a good problem to begin with. So let's do it first with the seat of the pants method, using what we know and what we maybe trust to some extent right now, and we're going to remember that answer, and hopefully when we do mesh analysis, we're going to get the same answer. Okay, you would hope that the two methods are consistent with each other. All right, so if I'm looking at this and I want to find VA, VA is here, and it's with respect to ground. Okay, if there's a single subscript, we talked about when there's a double subscript, but if there's a single subscript, it's wherever that node is with respect to ground. So that VA is going to be the voltage here with respect to this node. Now I could take it across these two if I wanted to, but the easiest thing for me to find the voltage across is that resistor. So that's actually VA. It's the voltage at this node with respect to ground. It's the voltage across that resistor. Okay, using some equivalent resistances, we can see that the 14 and the 10 are in series, okay, because they share this node exclusively. Okay, so 14 plus 10 is equal to 24. All right, so we can redraw that. Scroll down a skosh. I think we should petition to have skosh added as an SI unit. It's just my personal opinion. Okay, so let's redraw that quick and dirty here. All right, it was connected to this node here, and it's connected to the ground on the bottom, and this is 6 ohms, and this is 24 ohms. And now we know that this is 24 ohms. All right, we got 21 volts from that battery, single cell battery on the left. We're still interested in VA, okay, which is going to be across here. Now, looking at these two 24s, they look like they're in parallel to me, and in combining them, I'm not going to lose the node, right? That's on the outside of that parallel combination. And since I'm not going to lose the node, I can still find the voltage across it. So let's combine these two, since they're in parallel. Parallel. Last video of the day. Doesn't matter to you. You're watching them in any order you want. Parallel. So it's going to be 24 in parallel with 24, also known as 12 ohms. Okay, so redrawing that one more time, we end up here, and we have 6 ohms and 12 ohms and 21 volts. So we're interested in this voltage. Okay, that looks like the current divider. Okay, so we had some equivalent resistances, both in series and in parallel. I guess we didn't do any KVLs or KCLs in this one, but we get down to a voltage divider, which is nice. So there's certainly some Ohm's law in the voltage divider when we need it. Okay, so write the voltage divider for that. It looks like we're going to get 2/3 of 27. So VA is equal to 21 volts, because that's across the series combination, and we get the ratio of resistances. We want to know the voltage across the 12 ohm, so the 12 ohm goes in the numerator, and we divide by the sum of the resistances. Okay, and we get 2/3 of 21, also known as 14 volts. All right, that's what we're looking for. And that was a little bit of seat of the pants. Not a huge problem. I don't want to start you out doing mesh analysis on a very large, complex problem. I want you to start out with this one. There's your 14 volts. I want you to start out with this one. Okay, so we can do it with seat of the pants. There's nothing wrong with that. But we have to have some intuition and maybe a little bit of luck. But as we build up our methods of analysis, you're going to find that we can do this in a really structured way. And if you can turn yourself into a little bit of a robot and just kind of go through the steps, you're going to get the right answer every time. And that's what I want for you. Okay, so I'm excited. You're excited. You better be. I can't prove it one way or the other, can I? You're on the other side of this camera. Anyhow, mesh analysis coming up next. Stay tuned and good luck.